So my project was a PVC pipe xylophone, and it's a forced vibration instrument. And a forced vibration instrument has a tendency of one object to be used to force another into a vibrational motion, because I use an old flip-flop to hit the pipe to create a sound using vibrations. So the sound will resonate, and the resonance is a forced vibration which matches the natural frequency of the object, and a large amplitude occurs. So the sound waves will travel through the open pipes, and the sound will be played. Depending on the length of each tube, pitch will be heard. And it's different in every single tube because they are different lengths. And the longer the tube, the lower the pitch, and the shorter the tube, the higher the pitch. So they're all completely different. And pitch is like the actual sound that you hear when the instrument is being played. I had to use different formulas to calculate the tube length that I wanted each pitch to be, and that brought harmonics into play for what I wanted to do with this. And harmonics are integral multiples of the fundamental frequency, and the fundamental frequency is the lowest frequency produced by the oscillation of the whole of an object. So the equation I used in order to figure out the frequency of each note that I wanted to use, and to figure out the pitch and that I wanted to use for each different tube, was the diameter of the pipe over 2 plus 13,397.244, which is the constant of sound over above sea level, the speed sound travels above sea level, divided by the frequency of each note of the note measured in hertz times 2. And to find the frequencies that I used, I Googled them. So these are the values that I got when I plugged everything into the formulas for all of the notes that I was calculating the lengths of the pipes for. To get the frequencies that I needed for the formulas, I Googled them. So these were just kind of rough estimates, because for tuning issues, I had to cut the pipes even shorter. These were just kind of like rough estimates as to where I needed everything to be and how long they needed to be. So after Googling the frequencies that I used to calculate the lengths that I needed, I need to use those to calculate the wavelengths of the waves. And the wavelengths are the lengths of one complete cycle of a sound wave that has traveled through each tube. So the wavelength equation that I used was the speed of sound all over the frequencies. And these were the final wavelengths that I calculated for all of the notes that I did. I also wanted to include a picture of a sound wave for an open pipe instrument, which again is what my instrument is. So this is what the B wave, which is the lowest note on my instrument, would look like. And again, the wavelength for it is 1.4 meters. So this is what it would look like. So the song I'm going to be playing is Twinkle Twinkle Little Star.